All right, class. So, just a word of warning. This might be a long video. I'm gonna try to keep it short, but I want to include. There's some problems here that are gonna like stump you a little, and I want to include them to get you seeing why. So, just a word of warning. Sorry, my computer just notified me of something. So let's get started. So, what you're gonna do is you got to make sure your show all work. You're going to solve for each system. You can use any method. Remember, the three methods are graphing, um, elimination. That seems to be the favorite right now. There's a lot of you guys like to use elimination or substitution. Remember, you have to use certain ones for certain situations. So for like elimination, substitution, so a lot of you guys like to just brute force elimination and be like, you know what, I'm gonna make elimination work. I don't care what happens, and it's not gonna work always. You'll see how in a minute. Like for number one, for example, that's when it really doesn't matter if you use elimination or substitution. I'm going to use substitution just because honestly, if I'm gonna feel like it'll be easier, and I'm gonna write that down. I'm gonna use substitution. So and I'm gonna use the bottom one to substitute. So that means I'm gonna make that. Whoops. I'm gonna make that bottom one. I'm gonna subtract x to both sides, and minus x cancels on the left side, so you'll be with y equals negative x plus 3. Reason why is because I'm going to put that equation into the y of the other one. So this is going to be x plus 4, and then parentheses negative x plus 3 equals 6. So I got to do that distributive property, right? So distribute that. Then I'm going to get x plus, or not plus, because 4 times negative x is negative 4x. And then 4 times 3 is 12 equals 6. I can combine like terms here, right? They both have x's. And because they both have x's, that's technically 1 minus 4, which here is going to be negative 3x plus 12 equals 6. I'm going to subtract that 12, right? Both sides. Because the goal is you want to get that x by itself. So to get it by itself, we're going to do, sorry, my equal signs are coming out really ugly. I'm going to fix that, sorry. 3x negative, and then equals, that's going to get me negative 6, which gets you a really nice number because x is going to equal a positive 2. Remember, same signs get you positive answers. So that's our first value, 2. Our second value, now we're going to plug it in. I'm going to plug it into the equation, this one here, because it's easier actually. So y equals negative 2 plus 3. Well, negative 2 plus 3, that's simple math, right? You owe me $2, you have $3, you pay me back, you're left with $1, so y equals 1. So my point is 2 comma 1. So that's my final answer. I can check it, but for the sake of time, I would recommend you guys check it just to see if you did it correctly and so forth. One word of warning, I think one of these does get you a decimal answer. I'm not 100% sure. I still have to double check. Moving on to number 3. Reason for number 3 is you're going to notice, I noticed some things. Some of these are set equal to each other. So this is y equals, or not equal to each other, but some of these have different setups. Because of this, I can use substitution again. Right? This is a really good opportunity for me to use substitution because one of them is equal, set equal to a variable. Set equal equal to a variable. I don't like how that looks. Variable. Oh, I ran out of space. Whoops. There you go. Variable. So I'm going to plug that in to the bottom one. So that's going to get me 2x minus, but I have that all of y is minus. So that means I have to put parentheses here, right? Kind of like what we did in the past. But now we're into a little bit of a tricky situation because I have a minus here. So I got to distribute that minus into all of that's inside. But remember, we like to imagine minuses when it's just like that as a minus 1. So this is technically net times negative 1. So there's a 2x times negative 2x, and then minus 1, and then, whoops, there's a 1 right there, and then plus 1 equals 0. So I'm going to do some math. I have negative 1 plus 1 here. That's easy. That's just 0. Okay. And then 2x minus 2x. Wait a second. That gets me 0, right? This is technically 0x, or just 0. So it looks like we're in a problem, but we're actually not. This is actually something special. We call this infinitely many solutions. So infinitely many solutions. We haven't really talked about this, but if you done your quizzes, this answer comes up. Infinitely many solutions. Basically what this means is if I were to graph this is the graph for this equation. If I were to graph the other one, it would be right on top of it. So what that means is if you put two and two together, is it's the same line. So infinitely many solution just means it's the same line. It's the same line. So basically that's what you're going to do, is you're going to plug that, or when those x's and y's cancel out, you get infinitely many solutions. So you're not going to get really many questions about it on your final. Basically, it's just going to be more, do you know what that means? Which, now that you see, you do. All right. Number 5. Number 5, I'm looking at it, and I think I'm going to want to use elimination on this one. So I'm going to use elimination on this one because I see that 9 and I see that 3 on the x's. That means I could combine them. So I'm going to convert this 3 on the bottom, and I'm going to multiply by negative 3, right? So I can get the 9s to cancel each other out. So when I do that, top one's going to stay the same, right? 3y equals 3. Bottom one's going to get me negative 9x. Well, negative 3 times negative 8, or positive 8, is negative 24y equals, and then negative 17. Cancel, or stack those up, cancel each other out. Now I have a negative 3y minus 24y. That gets me negative 27y. Now I have a 3 minus 17. That's going to give me negative 14, right? The bigger number is negative, so that stays negative. Now here, this is the one where I think it's a decimals. So here we're going to get, let me see. So I'm going to divide that negative 27 to both sides, right? Negative 27. And you're going to get y on the left side. But on the right side, I have negative 27 or negative 14 over 27. So as I'm typing that in the calculator right now. So, 3x plus 8y equals, so, I lost give me 1 second. So 14 divided by 27. That's going to give me a really ugly decimal. That's going to get me 0. It's going to be a positive, by the way, because there's two negatives. 0.51. Whoops. I'm going to do 3 decimal places to be safe. 9. All right. Now, for the other one, actually, this might be the only decimal one. You're welcome. So now I'm going to plug in for the x, right? So I'm going to plug it into the top one just because I feel like that was the easier one. So negative 3 and then parentheses 0.519 equals 3. So now when I do that, that's going to get me, so I'm going to type that in the calculator, times negative 3. That's going to get me 9x equals negative 1.556 equals, and then 3. And you're going to get 9x, right? Because you got to add that 1.556 plus 1.556 equals, so then 3 plus 1.556 is 4.556. Then you're going to divide that. Answer divided by 9. You're going to get 0.506. So sorry about this one. We got this from your guys' book. We wanted to use your book for this final practice, and it was really good in theory, but unfortunately it gave us a decimal. But it's okay. That's what calculators are. Luckily, this is the only one that's in decimal form, actually. So we did that one for you. You're welcome. All right. Next up. So, I'm already at 10 minutes. All right. So, number 8. Actually, I'm not going to go over number 8 because we already did a substitution problem. So, I'm not going over number 8. All right. 13 through 15, I'm not going to go over those because of what happened, or you guys should be able to do it. All you have to do is remember, where do they meet? So, and when they don't meet, what does that mean? And solve the equation. This is pretty straightforward. So we want to find out what x equals, right? So to do that, we want to get x by itself, but I notice I have 2 x's on each side, so that means I got to move one over. Remember, you want to move the smaller one. So move smaller variable. So I'm going to move that 3x, but remember you got to do opposites. So you're going to do subtraction there. Cancels out on the right side, so it gets you 24. On the left side, you have 7 minus 3x, which gets you 4x, right? Divide by 4, divide by 4. X equals whatever 24 divided by 4 is, which gets you 6. So x equals 6. All right, pretty straightforward. I can plug that in and check it, but for the sake of time, I'm not. And then I'm going to do number 19 here. So for this one, I'm going to try to do one and then see what happens. I'm going to pick, looking at this, let me see. I want to pick one that might work or might be easy for me. I might pick, let's see. 4. I think I'm going to pick B. Now, it really doesn't matter. I purposely picked B because I believe that might be the right answer just off the top of my head. But I'm going to try it. I'm going to check. Remember, your guys' goal is you got to pick one and then just keep plugging it in until you find it. We've actually done this before. So, I have 5x plus 2 equals 2y. Right? The x is going to go there. The y is going to go there. That's x, that's y. So let's see. 5 parentheses 2 comma or plus 10 equals 2 parentheses 10. Right? 5 times 2 is 10 plus, whoa. I don't know what I did there. Whoops. 2. Now, I'm going to distribute that, right? 5 times 2 is 10. 5 times 2 is 10 equals, and that's 20, right? Well, 10 plus 10 is 20. Well, 20 equals 20, so I guess really well. If you pick the other ones and it didn't work, that means you did it wrong, so you have to keep going. Please do not, some of you, if you did pick the wrong one, don't erase it. Just cross it off and keep working on it. I want to see those mistakes. I encourage that. Let me know if you have any questions. I'll talk to you guys soon.